All right, guys. So quick video to cover this particular archetype. These kind of vertical twisting strips as facades that you see in this project here, Facade Liverpool, or this football stadium in Bilbao, and actually local to Detroit, the Henry Ford Hospital parking structure with these precast vertical right ribbons, and really kind of designed this in a way to allow for both like the controlled rotation, but also the kind of location of the seam, right, where the twist is actually happening, right? Now, if we do look a little closer at this particular project, you will see that for the assumptions for this particular script, we're going to assume that the bottom face or the bottom side is kind of flat and the top is flat, although these can be easily kind of changed or adjusted, right? But we're going through one full 180 involution, and we're going to be able to kind of change the let's say the waist, right? Or where the twist actually is happening as it is in this particular project as well. So with that out of the way, right? So I have a very simple file here, one straight line, one curved line. We're going to use the curved line first, the straight line first, just as a sort of basic input, right? So just with a simple curve component, let's link one curve in, right? And as you can imagine, so the idea is to break this curve into multiple segments, right? Kind of copy or move two of them vertically, right? To create a kind of three-tier system that we can loft through and then be able to kind of rotate through. So as you can imagine, we're going to divide the curve into equal length segments. So that goes into there. This number, of course, can vary. So let's do 0 smaller than 30 for now. Oh, accidentally pulled in Kuka. 0 smaller than 30 slider. Okay. And actually, we're basically what we're going to get here is I move this to, let's say 20, essentially 20 division points, right, on that line. Now, eventually, I'm just actually going to just redraw these. So I'm going to search the polyline with the P line. So these are individual segments. You could kind of do a break and shatter and all that stuff. I find this a little bit easier. And then to explode the curve into smaller segments. Okay, so what this gives us is like each individual segment. That's why eventually it will work on the curve surface, on the sweeping curve, right? Is that these will be kind of individual line segments that we can kind of operate on now, right? Now, I know this is the bottom edge of that facade. So, if you want to label things, you can just say, let's say bottom, oops, so loft profile, right? Just so mentally for yourself, you can kind of like keep track of where things are. Okay. All right. So simple move with a z vector, unit z, and a multiplier. This will depend on seam size. So I'm going to do 0 to 400. Let's see where that gets us. So this goes there. Okay. So that's essentially a Z translation. This eventually might be 200 or 400, depending on whether or not this ends up being like the middle or the top, right? So that's kind of how I'm going to eventually bracket things, right? So the basic idea is that copy, paste another one, right? So one set's going to be up here at 400. The other set's going to be here at 200, right? So we have kind of three loft profiles stacked vertically. And eventually what we can do is to kind of rotate the profiles, right? And by controlling that. Now, of course, at first, we can use a rotate, let's see, rotate axis, right, with a plane. So that's around the rotation axis. We have rotate. Yeah, okay, that's a rotation plane. Okay, so we know, I mean, because we know this is kind of rotate flat. So this is the one that should work for us. Okay. And so with that move, that's the top, this is the middle one, right? Right now, that's the middle one. And this is the top one. And so, you know, we can kind of rearrange things, let's say, to kind of keep things straight if you want to. So put that there and this, oops, sorry, and this one there, bottom, right, say, right, middle, and top, right? So eventually the middle and top both will need a rotation, right? So we can kind of do that, but here, very simple geometry to rotate, rotation, angle, and radian. So usually the shortcut, just right click, set it to degrees, right? So you can kind of use a simple degree input, 0 smaller than 180, as a rotation input. And the big thing here is this, right? So at first, right, it will kind of use probably the XY, right, 0 as a rotation plane, right? Because this input is the world XY, right? So now we have to give it each kind of like an individual rotation point. So what happens is we have to like take all the, so from here, right? All the individual kind of little line segments that we have, if I bake this, right, there are 20, yeah, 20 little line segments, right? So we're just going to find the midpoint on it. So curve middle, right? This is the midpoint of those things, right? Um, so this will all give us essentially, right, 20 rotation, let's say centers, right? So this will feed into the P, right? And now you'll see that the rotation, right, 0 is based on each midpoint now, okay? So this basic kind of like structure actually will happen both for the top and the middle, right? So I can actually just Control C, Control V, and make sure to transfer these correctly, like that. Okay, now, so the top profile, like this for now, I think can be set. I know like in the previous, let's say, sort of image that we saw here, right? These are kind of going through a full 180, right? So I know for the top profile, this is kind of basically kind of the full 180, right? Sort of revolution, right? And this rotate, again, you can kind of Control G and say, okay, that's the top, right, profile, just to keep things straight, okay? Now, the middle one is actually the one that I think we'll actually have to do a little bit more work on, right? So one of the things that kind of helps with this is actually having kind of more, especially, right, given the example where like the seam of this is kind of uneven, instead of trying to specify, let's say, rotation angles like I am right now, right? All of these have a single, right, rotation angle. We want to be able to do this differentially, right? And of course, you can kind of, pass it, let's say, 20 different numbers. But the best way to do something like that really is through the Graphmapper, right? So search for the Graphmapper. Now the Graphmapper will require a kind of corresponding range, of course. Something like this really likely is the Bezier graph type. So right click on the Graphmapper, graph types, Bezier, right? And you can kind of pull the corners down, right? And so basically kind of use this as a kind of control curve, and you can kind of widen it a little bit, right? Now, I need to set or feed it essentially kind of like a number range that correlates to how many, let's say, of these rotation angles I need. So that actually literally is our count, right? How many of these I am trying to kind of set up, right? So to do that, actually really simple is to create a number range, right? The number range asks for the domain, which by default is 0 to 1, which is fine because that maps over to the Graphmapper's domain range of 0 to 1. So I don't need an input in here, although I tend to try to make this explicit, right? So you can kind of, need a space between that. You can actually set it explicitly this way, and then number of steps. So this actually comes from here, right? There's 20, and what this will give us is essentially a number range 0 to 20, actually sort of numbers, so 21 in this case, right? Numbers that range from 0 to 1, right? Okay. So that range essentially gets fed into the Graphmapper. And essentially we can use this Graphmapper as a way to both, well, at least at first, actually both move the heights differentially, but also rotate the angles differentially, okay? So this move, which originally has kind of like a overall, right, this is kind of like halfway number, right? We're actually just going to eventually kind of inherit this like overall top line number, right? But we're going to kind of use this Graphmapper essentially as a modifier. So basically, you can kind of see this as like 400 is the top, 0 is the bottom, 200 is the middle, right? So we're going to kind of set it up that way. So I'm actually going to get rid of this slider first, right? And essentially coming from the Graphmapper, we're going to do a multiplication, simple multiplication from the Graphmapper, right? And then from the z vector that's been multiplied by 400, right? Here, that then gets fed directly into the move. So I can actually get rid of that guy. Okay. So what that gives me is essentially, right, that the height of, right, the middle seam now, that loft location is now driven by this Bezier curve, right? So there you can kind of see, right, its height adapting. So of course, if I move all this to the very top, then it will basically kind of overlap with that top line seam, right? So vice versa. So you can just kind of conceptualize this as, right, essentially 0 to 400, right, based on this. What's nice is that then like this entire, right, kind of height sort of adjusts, right, with a single parameter, right? We can kind of set the overall height this way. Okay. So we have control over this, right? Now, we can do the same system, right, to control our rotation, right? So I would just take the Graphmapper and duplicate it right again down here. Okay. And in this case, also by using the multiplication, and we're going to kind of insert it into the rotation part, right? So again, this number, this angle kind of like disappears. We don't need that angle anymore. The Graphmapper input comes in first, and then we need basically the same kind of overall rotation. Now, you can kind of base it off of this like 180 that we have up top, but in this case, I just want maybe independent control over this, right? And then degree to radians. So you can double click search rad. So this changes the degrees to radians that gets multiplied and then replaces our degree sort of input. Now, this case, I'm going to undo that because we did the degree to radian conversion kind of earlier on. Okay, so if I kind of, let's say, change this, then you'll see essentially, right, our, kind of rotation angles, right, should be, Let me make some more drastic. Right, our rotation angles, right, up top here are kind of almost 180. And then here, right, this is almost to zero, like, this is probably closer to like 10, 15. The middle is like close to 90, right? That's kind of right here, right? Now this overall can also be adjusted, right? So this is controlling like the overall rotation, kind of, let's say, amplitude. Okay, and then so this guy is our mid profile. Okay. Now sometimes, of course you can kind of rearrange this, right? But put the two graph mappers more or less kind of like on top of each other. Reorganize this however you see fit to kind of like try to keep things straight. But here I'm just kind of doing like bottom, medium, top, so it's easier for me to kind of keep track of kind of where things end up, right? All right. Now, I know that eventually we're gonna loft this together, right? And if we loft it, we need to kind of merge these streams. Now, of course, you can kind of like click and drag, shift, like combine them and do them in sequence. For some of these, it's actually just better to kind of do it with the merge component. And just to note that because these are kind of like in an entire right list, right, continuous list. So if I did try to loft this, right, basically this loft would be kind of running through that whole list like horizontally, right? It's trying to loft all the top profiles together, right? So that doesn't quite work out, right? So what we would eventually need to do is graft all of these into, and I'll just do this for the sake of showing you guys, is to graft all of these into individual lists, right? And so when all three, the top, mid, and bottoms are grafted and are lofted together, then it knows the first one is the list is locked into the first one in this list, is locked into the first one in the bottom list, and vice versa, right? So that's kind of the idea behind this, at least data structure wise. So this should go in sequence. So top, mid, and you'll see this automatically gains a new, right, kind of input, and that goes into the bottom, right? Those are the three that we need, right? And this actually will probably fail, or yeah, it will do something weird like that, right? Because everything's basically kind of being done in sequence, right, as one continuous list or line, because this input or this output has basically put them into one giant long list. So we need to basically graft these inputs, graft. And so you'll see some parts of it working now, right? As soon as, and you can actually delete the D4 by zooming in and click on the minus sign, right? So this makes that structure, right? So it's picking the first one from each, putting them into a single list because now those are the three that are merged. And now the loft kind of understands, right, what we're trying to do. So, and now that we're here, you'll see this is actually quite similar. Of course, if you want to control the top, right, then you can kind of control its rotation this way. Overall rotation, how much rotation is as a kind of overall parameter is controlled using this guy. 35 seems good, right? These two, again, this controls kind of the location of that waist seam and kind of where it is. And then this obviously kind of controls the amount of rotation, right? So you can play with those parameters to quite a fair bit, right? Second, actually, just as an aside, of course, we have loft options, right? Which we can kind of use we don't want to close loft, we may or may not want to adjust seams, right? And then you can kind of look at the different kind of loft types, right? Whether it's like normal, loose, tight, straight, to kind of change the sort of loft outcome. So this in particular, right? So the slider 0 to 5, right? So 0 is smaller than 5, which is kind of 0 by default. And this kind of might come into play because you kind of saw sometimes with certain rotations, like the edges, if it was a normal loft, can get really bulgy or wide, especially if I have, let's say one of these really far off up, right? Then you'll see the bottom, right? This part kind of widening a lot, right? So, and that's why this, right? Kind of changing the loft option sometimes, right? Will give you a little bit more, that's a straight loft, give you a little bit more degree of control, right? And so like type one probably deals a little bit better, right? With these like really high kind of profiles. I'm actually noticing that there's a sort of second thing right there, which means my range, this actually might have to go down one because this is probably 21 values, right? So uh, just to make it explicit, subtract. So this 20, oops, 20, right, minus 1 can go to there before it gets fed into the range. So we have the right number of uh, section profiles there. Okay, so and that's it. These are the options. Oh, and of course, this is kind of like the straight, sort of like straight version. Go back to one, it's a more three-dimensional, but move the scene down to kind of location. So there's kind of like a relationship between, right, all of these things, right? So you can kind of play with it to kind of discover like the right expression. Now, final thing, of course, like we can actually set this to the curved, right, sort of surface as well. Sorry, the curve as well to kind of generate that, right? And of course, this can work on something like this, right? This is kind of discretized into straight segments. So, yeah, that's the sort of very quick and dirty sort of version of this. Of course, if you do more, let's say loft segments, right? You do, 3, 4 in there, then you get much tighter control over the geometry. A lot of the sort of bulging at the ends is because it's trying to make the tangents right in between all work. So if you do these right, kind of a couple more, then it will straighten out, especially the kind of vertical, right? But for the demonstration purpose of this demonstration, I think this is kind of good enough. All right, that's it.